Hi, I'm looking at integration here in this audio class of mine. Now, integration is adding up of things, but what do we exactly add is the question. Some people might look at it as an inverse of differentiation. Uh, so the idea here is that we add up things to find out what the final number is. I'll give you a very simple example here. If a ball is falling from a height and you keep on adding the distance that it traveled since it started to fall, that's a kind of addition that you do. So in the initial time it was small distance in the first second, higher distance in second around. So we are looking at adding up things. It can also be conceived as area under the curve, because we are adding those strips. There are two ways to look at it. You can have a summation of those two things. But as far as your interviews and as far as the ACT exam is concerned, they don't ask too many formulas. They require you to know only a few. The first is the integration of x to the power n is x to the power n plus 1 divided by n plus 1. The integration of 1 by x is log x. The integration of f prime x by fx is log fx. The integration of a to the power x is a to the power x by natural log a, and the integration of e to the power kx is e to the power kx divided by k. So those are the things. Suppose they give you the integration of root x, it's x to the power 1 by 2, so you should be 1 by 2 plus 1 upon 1 by 2 plus 1. If they give you 7 to the power 2x or something like that, then a is equal to 7 square. So based on that, you're going to do that. If they give you exponential something, you'll do that. Those are the things. Now any of the types in e to the power x, you might have a constant there, so while you integrate that, you bring that constant outside in such a way that it does not create a lot of trouble with you. So that's how you're going to integrate that. Okay, so some of the times you cannot directly integrate some of the numbers, so what you can do is that you can use something called substitution. So when you substitute it, suppose you have x into e to the power x square, so you can substitute x square st, and dt would be ex. So those are the kind of things. So integration by inspection or substitution is one way you want to look at. Now there are integration by partial fractions, where you would break something down and integrate that. So if you've got a big thing, you would break it into smaller part and do that. So that's another way. So you'll take an a and b and find out the value of a and b, separate them, and once you have something in the form of log, you can integrate that. So for example, integration of x minus 7 divided by x square minus 1 or something like that, you would do that. Then integration by substitution, that is change in variable. Now in finance, it's quite interesting thing. I am coming from an engineering background, so I saw a lot of sine and cos and trigonometry integration, but that's not your concern now, so that should not be a problem for you. Next part is differentiating and integration. So that's a Leibniz formula. So if you take a differentiation of an integration, how you are going to do that, and that's again. Then we have convergence, on how things would converge. This could be only done when you put in some of those values. You have double integral, which is quite interesting thing. Now double integrals uh, are actually area under the curve, and it's like dx dy f of x. So what you are actually doing is that you are taking out z and dx into dy into c, and you are adding that. So that's like volume. We are going to look at more into that, the area under the curve part. And then you have triple integration, that becomes interesting. Swapping orders of integration, and so on. So then you have numerical methods for integration. See long formulas. Then you have Taylor and Maclaurin series, that would and this. So that's about the integration.